Hello everyone, I'm Piotr. I don't know whether any of you have been to RubyConf this year, RubyConf Portugal. Okay, if you haven't, and you haven't seen the Ruby Smalls talk online, then you're good, because this is like fully fresh talk. But if you have, it's a pivorak edition. I will explain what I mean by it in a second. I'm Piotr, I come from Poland. This is more or less our coat of arms. I'm super excited to be here. I kind of traced pivorak a little bit. I learned about it from Andrzej Krzywda, who I think spoke here a few events ago. And yes, super thankful for the very warm invitation. I'm being taken care of wonderfully. So I'm super thankful and super happy to be in Ukraine and in Lviv in particular. And by pivorak edition, I mean this talk usually, like the previous time I gave it, it starts with very slowly with some introduction, explanations, you know, the kind of academic stuff. And from what I learned about pivorak so far, I might be wrong, but I think I gauged it quite well, is that you're much more into practice and code and, you know, let's get to the good parts first. So I'll start with code examples, and then, depending on how much time I have left, I will go back to the more of formal stuff. So we will go through a few code examples of issues with object-oriented programming, and we will see what we can do with them, maybe recognize some patterns. Those code examples, there are a few caveats here. First, I will use instance variables. Again, as we heard before, there was this very gentle suggestion that maybe they aren't everyone's favorite. They are also not mine's favorite. But I will use them in those examples to very clearly denote which parts of the code are belong to the instance of a class we're talking about. Just assume that those instance variables are set in some kind of constructors or dependency inject or whatever way you like it this month. If you're an active developer, it probably changes over time. And you know, in winter you prefer explicit constructors. In summer you prefer, I don't know, overriding methods in tests and so on. There are different ways. All of them are excellent. All of them are also absolutely abhorrent. So kind of depends on your take. I will skip the constructors. I would use getters in actual code. I'm one of the people who actually prefer to use getters even for like very simple instance variable access. And some of those examples are very badly refactored. And I probably shouldn't say because I couldn't figure out a better way. I should say that because sometimes refactoring ends up in something that is worse. And those examples are there to show you this. OK, so let's say we have a Meetup class, because we are at a Meetup. And we have a weather assessment method on it. So this method consults some kind of weather source, which is somehow put into that Meetup class to check the weather at the current city of the Meetup. And for that weather, first it checks whether skies are clear. If they are clear, then it means it's definitely too sunny for doing any serious programming. It's super distracting when there's sun outside. So if not, then we check the temperature. If it's over 20 Celsius, I assume most of you are kind of like me, not very Mediterranean from birth. So let's say that over 20 Celsius is a bit too hot. Otherwise, it's perfect for coding. So what is the example problem that you see in this kind of code? Do you have any? Like, what would be your first disagreement?
Not scalable.
It's not scalable. Good. Why it's not scalable?
Hard-coded degrees.
Well, yeah, this is hard-coded. The whole business rules of this class, that what it means for a weather to be like good for coding are like super hard-coded. This is not taken out. But let's assume that we're building a really MVP. And also those examples, you know, I wanted to fit them on a slide that actually let you read them in one sitting. So there are like most of them are really simplistic.
It doesn't fit to the metal law.
It doesn't what? Sorry.
Violates the law of dividend.
Yes, that's also a good point. So we ask the weather source for the weather, and then we assume not only that the weather source has a weather at method, but also that whatever the weather at method returns has a skies method or a temp method. So this, we basically are reaching a bit too far to get the weather. But my point, like, of course, these are all good things that should be refactored eventually. But the thing that I wanted to talk in this example is that we query the weather source for the weather twice. And if it's actually any kind of real-world code, this might be like a third-party service that we query over the network. And in general, you see, like, we do those checks like right after each other. I know Ruby is not very fast. I spoke about it just a few minutes ago. But in general, there isn't going to be a lot of time between those two queries. And we will most probably get the same weather. So we really should factor out at least this weather source, weather at city call to a separate line that will cache the result, so to speak, put it in an instance, put it in a variable, and then just check that variable about weather. And of course, all of the subsequent refactorings where we actually do something like much more proper with this, like address the law of Demeter violation. Yeah, so like the obvious change, like the obvious argument for me for this is that there's something that is called duplicate method call. And this is when the same call is made more than once. If we do more than one, the same call more than once, it can have really adverse consequences. So refactoring is like super simple. I will start this talk really with simple examples. Caveat, readability. This is usually not a very controversial change. A lot of people assume that if you refactor this way, we extract a method call into a variable that's an obvious refactoring. And it's true in many, many cases, but I will show you in a second two cases where this actually, in my opinion, it's bad for readability. So this would be like the most obvious refactoring, just store the weather in a variable and then ask it for the skies, ask it for the temperature. Notice how it's less obvious that we have a law of Demeter violation here, but we actually still have it just the same. We assume that the weather source gives us weather and that the weather gives us skies and temperature. So eventually we should of course address these, and there are very good comments, but like for starters we should probably address the fact that we are querying the weather source twice, and if the weather source doesn't do any caching, then we would actually do, for example, two network calls for absolutely no reason. Okay, let's go further, and let me show you those two cases where I think readability might trump this smell. So let's say we have a matrix of things, as we had in the lightning talk, and we check whether two things are separated. So for example, this is a matrix that checks whether things are separated from each other, and if there is a 1 in that matrix, then it means this is separated, and if it's 0, it means they are not separated. So first thing, we have to check whether even there is a given row in that matrix, and then if it is there, we check whether the given row and column are non-zero, which is 1. And technically, this is a duplicate method call. We call the square brackets method on matrix twice. This might be inefficient, might not be inefficient. If we had any good compiler, it would actually compile it away to just to do a single call. But I would argue that in this case, writing row equal matrix row, and row column non-zero is actually less readable. For me, like this line is super readable. In this case, these are all examples from quote-unquote production code. This is from my PhD, and in this case, there was a method. As you can see, I don't shy away from hard coding values as long as I don't have to change them. So in this particular case, you have the same call, which is, this is for, it doesn't matter what it really does. It takes a digital circuit and it checks how many quarters of a circuit it would take to implement it. So if there are fewer or required than 5 inputs, then it takes the number of outputs divided by 2 and rounded up. And otherwise, it takes the larger number from 1/5 of the inputs and half of the outputs. And in theory, this is a duplicate method call, right? This number of outputs divided by 2 and rounded up, these two calls are exactly the same call. But if you think about it, first, this code would ever only take only one branch. It will either make this call or make this call. So extracting this to a variable will not actually, in this case, make it any faster. Actually, it will make it slower if this branch is taken by the code later. So if we extracted this here, then this case would get slower because we will have to count this. Of course, these are like very simple calculations, and nowadays Ruby can actually make them in a way that is not super painful. But also, this whole logic is, in my, at least in, I believe that is much simpler to reason about how the flow goes. If we extracted this here, then we would basically say, for some reason, I need to pre-compute the half of the number of outputs, and then maybe use it and maybe not. Like every time I would look at this code, it would confuse me a little bit. Whereas this logic is basically, if there are no inputs or no outputs, then this circuit, this function will take 0/4 of a circuit. If there are fewer or equal than 5 inputs, it will take half the outputs, and otherwise the larger number of those two. So there are cases, even though this simple refactoring is questionable, and of course you can disagree with me that this is a good example of where readability trumps refactoring, but I ended up with going with this code even though the smell is technically in here. Okay, let's go further. Let's say we want to get to our meetup. So the meetup implements the directions method that takes a latitude and longitude, and also want to know a distance to the meetup and whether one needs a passport. I got used to travel without a passport so much that actually my passport expired. So this method is something that I would actually have to call, and I have a brand new passport in my pocket because I made it to get here. So what do you see that is very kind of has a certain cadence for those three methods?
Compilation of parameters.
Yes, like all of those methods not only take latitude and longitude, they actually pass it further to some kind of navigation source, pass those latitude and longitude and the latitude and longitude of the meetup in question. So we have like, it's probably, like I probably overdid it a bit, but I wanted to make it really clear that what we have here is called the data clamp. We are passing the same, in this case, pairs of data all over the place. So this one happens when the same set of variables is passed in many contexts. And this can be, whatever, like first name, last name that don't belong to an object that represents, a user or a person. There are only two industries that call their clients users, right? Ours is one of them. Refactoring is create a composite value object with the caveat, make sure that the clamped variables are actually related. There might be cases in your application where you pass first name, last name, and some other information that is not really related to the person in question. And in this case, obviously, you want to extract the first name and last name to some kind of an object, whereas that third thing, even if it's passed every single time, like putting it in the same object might be way overdoing this data clamp addressing. So make sure that the clamped variables are related. And the obvious solution here is create some kind of struct that has latitude and longitude, and then we can pass it as a source location. And of course, we will have to teach our navigation source to interpret a location object rather than a latitude and longitude. But if, like first thing first, like anytime you hook into some third-party code, we assume that we didn't write the navigation source, we got it from somewhere. A good practice would be to wrap it up in a even very thin layer of your own code, so we can actually, if you need to, this is your navigation source, and you basically unpack the latitude and longitude in that code. Or if you really wanted to talk to a navigation source that actually requires a latitude and longitude, if you put a little star in front of it, Ruby would explode this struct into latitude and longitude. So even if we talk directly to a navigation source that needs two numbers, we could still benefit from having a location struct like this. So let's go further. Let's assume that not all meetups have location, or not all meetups have location set. So for all of those methods, we actually first have to check whether we have a location set. More or less obviously, like I don't know how many legacy projects. Legacy is this awful word that means that something actually works in production. So I don't know how many legacy projects you work with, but this is a pattern that actually happens quite often, which is basically we defensively check whether location is set, in many, many different methods. This is called repeated conditional, when we check the same thing over and over again in different methods. So refactoring, there are many different refactorings, and all of them are questionable. For example, we could say we have a located meetup, which is a meetup that has a location, and regular meetup that doesn't have a location and doesn't have those methods, or actually has some kind of stubs for those methods. So, or we could have a null location. Null location, which is a location-like object, which we use when we don't actually have a location, which might be a better solution. In this particular case, it might be also questionable, because then ideally we should make nav source work with null location, because if you ever saw those little pins in the middle of Atlantic Ocean, is when somebody didn't have a location and set 0, 0 as the coordinates. So if your navigation source doesn't expect to have a null location, it just assumes 0, 0 as the defaults, then you will get all of the directions from the middle of the Atlantic Ocean. And sometimes, again, readability can trump a purer design. OK, if you have any questions at any point, please ask them. If not, then let's go further. Let's say our meetup. I am one of the co-organizers of the Warsaw Ruby users group, which we call VRUK by short, which is the first initial. So let's say our meetup, we initialize it with a name which can be nil if we don't know how our meetup is named. I told you those examples might be a little bit contrived. And then we have an acronym A, predicate, which checks whether the name of our meetup consists of uppercase letters, unless it's nil, in which case, if you know Ruby, you know what happens. This method returns nil. So first, like a little bit of trivia that you probably know much better than people at more kind of Westerner conferences. There is a way of telling Ruby, and actually it's Oniguruma, regular expression engine, that we want uppercase letters. We don't want A to Z. We actually want uppercase letter. And you know much better than me that there are many more uppercase letters than A to Z. And actually, Unicode support is really, really, really good in Ruby once you learn all of those Oniguruma character classes from Unicode. Actually, this is, and you can say, you can have very different character classes. I highly recommend, if you ever do any kind of regular expression matching on text, especially if it's not, basic English text, then to learn about those things. OK, so this aside, what's the problem with this method? Well, the problem with this method, which is actually a little bit controversial, is that we really shouldn't do this kind of calls in a pure object-oriented code, which is called the nil check, which is usually it means there's a missing type in the system. For example, maybe the missing time is a null meetup. Maybe the missing time is meetup that doesn't have a name for whatever reason. But also, again, I urge you not to sacrifice simplicity for the case of pure design. I will go back to why I'm telling you all this later in the talk, but please always keep in mind that sacrificing readability or maintainability of your project just for the sake of fulfilling some academic ideals is usually not a good thing. So let's say we have a name meetup that has always returns false for the acronym. And again, this is a philosophical question whether unnamed meetup is all uppercase or not. But then we can have a regular meetup that actually requires a name and actually doesn't have this nil check here. And to make this all work with existing code, we can override the new method on meetup. And if there is a name, we will call super. And if not, then we will create an unnamed meetup. So all of the existing code still works, even though we now have a meetup that doesn't do the nil check and unnamed meetup that also doesn't do the nil check. You can actually, of course, argue whether this is not a nil check in disguise, but this part is only for the sake of backwards compatibility. Also, see that I didn't do inheritance here. I didn't say that unnamed meetup is a meetup that doesn't have a name. I didn't say that meetup is an unnamed meetup that has a name. And of course, this is a very basic example where probably meetup would have a few more instance variables, and you wouldn't want to make meetups with various meetup classes. But in general, inheritance, I think, is overused. This is a wonderful quote from Sarah May. it would be so easy to make an admin a subclass of user. No, don't do. You've got the rest of life ahead of you. If you're tempted to use inheritance, always think twice whether you don't really want to do composability, you don't want to have separate classes, because maybe the things that you're trying to represent are actually not that closely related. And inheritance is not for sharing code, it's only for things that actually have a very strong relation to each other. Okay, let's go further. Let's say that our meetup has instance variables that says what languages are being discussed at the meetup. And we can query the meetup, whether it's about Ruby, and we consider it to be strictly about Ruby if it's only about Ruby, and non-strictly about Ruby if it has Ruby as one of the languages, right? So I don't know what's your language structure here. We in theory, Warsaw Ruby users group is strictly about Ruby, but then we had very recently a meetup where we had no Ruby talks whatsoever. And in general, this is considered to be a good thing because it means that the Ruby ecosystem grew out of discussing, slides and slides of code to discussing, very different ideas, which I also try to mix those two things here. So the way it works, we pass a Boolean value here, which we default to true. So if we call meetup Ruby question mark, it actually checks whether it's strictly about Ruby, and otherwise, if we pass a false flag here, then we only check whether it's about Ruby among other languages. And this is, in general, a very bad API. If you ever had a method that takes a flag, and the flag can be true or false, usually it's not a very good API. If you remember the Gosu examples where you have positional arguments with 6 different numbers, and you have to remember which number is what does it mean, it's not it's better than this, but it's still not super useful. But this case where you have, especially when you have a predicate that you pass an argument, and the argument is true or false, if you look at the code that calls it, you have no idea what this predicate means. So what this is called, this problem is called Boolean parameter, and it's when the caller directly controls callee's code execution. Here, the code that calls this method exactly tells it which code path to choose. So there is really no reason for this method to look like this. The caller already knows whether it will execute this half of the method or this half of the method, depending on what the flag is. So refactoring is, for example, one of the refactorings is to split into dedicated methods, and caveat, consider caller usability. So in this case, we could create 2 methods, surely Ruby, which checks whether the languages are, there's only one language at a given method, or possibly Ruby, whether all of the languages include Ruby. And again, from the pure point of view, this is a better design because the caller already knows whether the flag is true or false. In practice, it's not always that good. Hence the caveat of consider caller usability, because sometimes the caller might get an object, like this flag here, from somewhere else, and not necessarily want to check whether the flag is true or false and call this or that method. That would basically replicate this code, but in the caller and all of the places that the caller makes. So that doesn't always make the method more usable, but it's purer and it's worth considering. And I want to drive this point home with the next example, which is the worst example that you will see here. And this is an example where you say that a meetup is interesting to a given attendee, and the attendee is some kind of a string for the sake of simplicity. And if the attendee is Pythonista, then the meetup is interesting if it's dynamic. If the attendee is a Rubyist, then the meetup is interesting if it's laid back. And if the attendee is Rustacean, then the meeting is interesting if it's about system languages in general. So I really wanted to put a Crystal programmer in here because I really like the Crystal programming language, but I have no clue how the Crystal programmers call themselves. So this is called control parameter. This is a bit like Boolean flag, but a bit more unobvious. So we take a parameter, and this method takes different code paths depending solely on the parameter being passed. So the caller knows which path the code will take. The caller, which is the code that calls this method. So again, if we do the refactoring of splitting into dedicated methods, you will see how this refactoring might end up with a simpler code and maybe even more proper code from the point of view of this method, but actually it will hinder caller usability. In this case, it's more likely that this refactoring would hinder Of course, you could use aliases here. You could use, whatever delegation you actually, I don't know, whatever delegation is fashionable this month in Ruby. But the simplest implementation would be this. And again, the caller knows whether they have a Pythonist, a Rubyist, or a Rustacean, so they know which method to call. But if they got this object, this attendee object, from somewhere else, they might not necessarily want to do the check. So this code might be actually less usable, even though it might be actually purer. So always remember, I hope I drove this point home really well now, always remember about code, about usability of whatever you do, even if there are technically code smells in whatever the code you're working on. Okay, let's go further. Let's say a meetup is successful. There's a predicate. We pass it a collection of attendees. We partition the attendees whether they are excited. If there are more excited attendees than indifferent attendees, then we consider the meetup successful. What is the problem with this method? Like, what do you think? How is this method related to the meetup class it's defined on? I take the silence as you all basically say it's totally unrelated, which is exactly the point. This is a utility function. This function is totally unrelated to the meetup it's defined on because the attendees which it works on are passed into this method as an argument. A method that does not depend on instance state in any way. And this method could be moved anywhere in the system. You would actually, the only thing you would have to change if you put this anywhere, you could put this on the kernel module, and it would work just as well. You would just change the receiver which gets successful. You could move it basically to string, and it would still work. Like anywhere in the system, you could make a top-level method, and it would still work. So the refactoring is to either move it to where it belongs, or actually, if it belongs to a meetup, then maybe attendees are a part of a meetup. So just remember that sometimes it's just a private helper. Sometimes we really want to do a very small refactoring where we have a bit of logic. We want to put it as a private method, pass all the stuff that it needs as parameters, and then maybe discuss whether some of those parameters are actually instance state of the object. So we could do this. We could say that the meetup actually consists of attendees, and then the predicate, whether a meetup is successful, doesn't need to have any combination from any other meetup passed. It just works on its own attendees. But also, maybe the right refactoring of this would be to not put the logic in the meetup, but the logic in the collection of attendees. So maybe a meetup is successful if its attendees are excited, and the attendees are excited when we have a collection of attendees. And if any of you just had a little mental breakdown on the inside because I subclass array, this is a very good reaction. We'll get to this in a second. But the collection of attendees are excited or not the kind of meetup. The logic probably belongs to the collection of attendees rather to the meetup. Another refactoring would be to actually have an attendees class that takes a collection and then partitions it by sending partition to that collection. So this no longer is an array, glorified array, because for many, many cases, I don't know, shuffling the attendees array doesn't make any sense, usually. So this is probably a better design where we actually have a composition. We hold this collection private, and we only delegate partition to it, and we say that our attendees are excited, given the same logic. OK, but let's go a bit further. Let's take a little more contrived example. Let's say that our meetup is successful if the attendees are either excited or the language of the meetup is Ruby and the attendees are Rubyists. Because by default, we assume that if we had Rubyists at a Ruby meetup, then the meetup is successful. This is a little bit of a low bar, but we also, in Warsaw, had to start at the beginning when we got 3 people in Warsaw Ruby users group. And as long as they were Rubyists, we were super happy. So let's say that we do this, which basically means we partition our attendees collection. And for every attendee, we check whether they are either excited by themselves or they are Rubyists and the meetup is about Ruby. And then we consider they really should be excited. Maybe they don't know it yet. So, and then we consider the meetup successful. And of course, to some extent, this has the same problem that we pass the attendees collection, but it also depends on a little bit of instance state. This method depends on whether the language of the meetup is Ruby. So we can't really just take this method and move it elsewhere. because maybe we don't expose the language of the given meetup and we don't know it. So this is not utility function, this is feature envy. This is a case where if you look at this method, it does depend on the instance states a little bit, but it actually refers to the attendees, the elements of the attendee collection almost everywhere else. It just checks this little bit of knowledge from Meetup. So partially refers to instance, but mostly to the arguments. And the refactoring is to move the code to one of the arguments and then figure out a way to pass this little bit of instance state in there. That's one of the refactorings. And again, make sure the knowledge is local to the problem, because in many cases, if you adhere to this refactoring very religiously, you will have logic that is about the meetup everywhere, but except the meetup class. You will have a bit of a logic in attendees, a bit of a logic somewhere else, a bit of a logic somewhere else, and sometimes it makes sense. It's definitely purer from the object-oriented point of view, but it might be actually harder to maintain. So, for example, we ask the attendees whether they are excited, given that the language of the current method is language, and then we basically say that we check every attendee when they are excited, given the language is language, and then we check whether the attendee is excited by themselves or they are Rubyist and language is Ruby. So here I also did one more step where I actually don't put the logic, like I put some of the logic in the attendees collection, but also move some of the logic to the attendee class. Again, the examples are simple and contrived at the same time, but you can get the gist that we basically pass only the tidbit of the instance state all the way down here. Whether this is a good design, it's purer. Whether it's better, that's another question. OK. This might be the next to last example. Let's say we have a very simple struct-ish like class, a simple value class that takes a city and a name, and we expose the city and the name of the meetup. This, depending on your approach to how value objects should operate, but in general, if you have public writers to objects in object-oriented system, this is called the attribute smell. In general, in most cases, having setters on your objects is bad. It means other objects that take your object can set your own instance state. So in general, it's considered to be at least questionable. There are cases where it's probably may be valid. There are times where this is a good speed-up optimization. But in general, when you're designing something from the ground up, avoiding setters is a good thing. For getters, it depends. If it is a value object, then to some extent, obviously, you need getters. If this is an object that represents something more, then maybe rather than asking it for its state, maybe you should pass it what you want it to do and let the object do what it needs to be done, depending on their state, rather than being asked about its state. Refactoring for the non-value objects is tell, don't ask, which is, again, exactly what I said. Tell the object what you want it to do, depending on its state, rather than ask it about its state and then do to it what needs to be done. For value objects and for getting rid of setters, one of the kind of very typical approaches is to have immutable objects that you can call update on or with, and then you can pass what you want changed. So I will show you an example in a second. Again, this might be an overkill in simplest projects. Caveat to the caveat, a lot of simple projects turned out to not be that simple a year later, because you wanted to have a 100-line long game, and it was so successful that, half a year later it has 10,000 lines, and you consider this an overkill, so you never refactor it to get rid of the attribute smell. And for this example, we only have attribute readers, but we can, on every meetup, we can call the update method. We can pass either a city or a name or both, and we will get a new meetup with those things. Notice that in Ruby, you can default keyword arguments to the instance variables, and those instance variables are instance variables of the object of that class. These are not instance variables of the class, which might be non-obvious, because you could think that in this context, self is the class, but in this context, self is actually the instance of this class. So you can do this, and then you can call, you can create one meetup, and then you can say the same, rather than setting the city of a meetup, you will get a new meetup with the same name and a different city as an example. This way you can have immutable objects which have a lot of advantages. For example, they make concurrency much simpler. There was a whole talk about this that was called Burn Your Getters. This is Tom Stewart in his one of many Rome's Caesars, so I assume it must be the one who was really good at burning. So if you go to the slides which are up online, I will have the link later. You can click this image and you will go to the talk that was all about burning your getters. So with these examples done, let's see about some real-world examples. I went only to the Ruby code base and standard library. There is a matrix eigenvalue decomposition Hessenberg to real sure method that has 433 lines. This is quite a lot of lines, if you think about it. Like, usually this means this method won't fit on a screen, and usually figuring out what it means, what it does, would be a problem. There is another method, tk item config method underscore item config info underscore core, which has 759 lines, and it's still not the longest method in the Ruby code base, because there's also rdoc markdown underscore code, which has almost 1,600 lines. With a big caveat that this method seems to be generated by the peg parser from one line of rules, so this really doesn't count. But like, those two methods are there in the code that you actually use, maybe not always, but you might be using even not knowing it, maybe the TK parts, hopefully not. I mean, I have a very strong sentiments towards the TK interface, but they are usually not those positive sentiments. I mean, you know, it works everywhere, which is a great advantage and probably the biggest advantage of TK. Also the only advantage of TK. Anyway, like, if you think that those methods, like, how can we use a language that has a method that has, 759 lines? Well, when you start a new programming job, you have to walk right up to the biggest function in the yard and refactor it in front of everyone. Like, you are more than welcome to go to those methods and try to refactor them. Actually, this would be beneficial. It would be beneficial experience for you as well. I'm not trying to say these are not refactorable. They certainly are. It just, for example, this method implements an algorithm from some scientific paper. It implements it step by step with a very long comment saying what does it do at the given point. And probably refactoring it to be much more usable might be beneficial, but also, again, remember that this is a dynamic language. Every method of extraction has a cost when you call it. So with this done, I'll briefly go through the kind of part that was a bit more academic, so to speak. The definition of a code smell, now that we know what example code smell are, a code smell is a surface indication that usually corresponds to a deeper problem in the system. And the thing that is important here is that the quick definition above contains a couple of subtle points. Firstly, a smell is by definition something that's quick to spot or sniffable, and the long method is a good example. But the second is that smells don't always indicate a problem. Some long methods are just fine. You have to look deeper to see if there is an underlying problem there. Smells aren't inherently bad on their own. They're often an indicator of a problem rather than the problem themselves. Oh, I can blank the screen with my remote. Good. There is another definition from the C3C2 wiki, C² wiki. And again, this is basically saying a lot of the same thing. The most important part is here. Note that the code smell is a hint that something might be wrong, not a certainty. A perfectly good idiom may be considered a code smell because it's often misused, or because there's a simpler alternative that works in most cases. Calling something a code smell is not an attack, it's simply a sign that a closer look is warranted. And I love this part very, very much. They're just rules, as Douglas Butters put it. Rules are for the guidance of the wise and the obedience of fools. So there are two major approaches to programming. Pragmatic, which says that code smell should be considered on a case-by-case basis, and a purist, all code smell should be avoided, no exceptions. And therefore, a code smell is a hint of possible bad practice to a pragmatist, but a sure sign of bad practice to a purist. So I would argue that if you haven't refactored your code for code smells, and I will show you how you can find your code smells in a second, a bit playing a bit to be a purist, especially on your pet projects that nobody else uses. So you're the only person who will be hurt by your refactorings. Playing the role of a purist might be very beneficial. It will teach you where refactoring code smell is way too far, like in the examples I shown before. I did do to some of my projects, I did refactor them all the way down to have no code smells where no is defined in the following slides. And then I have to refactor back to something that is actually maintainable and usable. So it might be a good experience to play the purist, but in general, being a pragmatic is probably the safer long-term bet, and actually will make you a happier programmer, if only because your team will also keep on liking you. So how can we find code smells in our Ruby apps? We can either go by hand or use Rig, and I will present Rig because I'm one of the maintainers. So Rig with this wonderful logo that was donated to us by Sonia Heinen. Rig is a very opinionated static code analyzer for finding smells. It's a bit like Rubocop for architecture. Who here knows what a Rubocop does? Okay, so you know what Rubocop does. It basically says like, you shouldn't put the comma here, it should go over there, and then you have like big fights in your team, or basically, there's this part of the team that uses single quotes where no extrapolation is needed, and they have to be, galvanically separated from the part of the team that always uses double quotes. Like serious problems in the Ruby community. So Rig is a bit like this, but it actually is, to a large extent, much more problematic because it says like your syntax might be okay if you run Robocop, but actually your architecture is a little questionable. So the way you use it, you gem install it, and if we had this Meetup file and we run Rig, no wiki links on it, it would tell us that there is a duplicate method call. The Meetup weather assessment calls weather source weather at city 2 times on lines 40 and 42. There's a data clamp smell because Meetup takes parameters source latitude and source longitude to 3 methods. There is a repeated conditional because it tests latitude and longitude at least 3 times. I actually skipped this part where you saw an example when we check if location exists, but Rig is good enough at actually, if you have exactly this conditional, even if it's like a conditional that goes through, 5 different conditions to check, Rig will track this and point to you that you have this whole logic in whatever many number of places you have. It will tell you that there's a nil check in the Meetup acronym method. It will tell you that the Meetup interesting predicate has a control parameter. It will tell you that the Meetup Ruby predicate has a Boolean parameter. It will tell you that this is also a control parameter because a Boolean parameter is a case of control parameter. It will tell you that the successful has a feature envy, and also it will tell you that it's because it refers to attendee more than self, so maybe you should move it to another class. It doesn't say that explicitly that you should move it to attendee class because it depends, but maybe it should be moved to somewhere where it's more connected to the state it works. And it has an attribute smell because the city is a writable attribute. And the last one is that it has no descriptive comment. And I don't want to get into a fight like just now about comments. This is one of the approaches. One of the camps says like, this is what code comments are, right? There are code comments and which tell you what the code does, and then the code does something really different. But also, there's this other camp which also often has at least a bit of a point, which is, war is peace, freedom is slavery, code is documentation. Like if you say that your code is documentation, you are asserting a very strong thing about the readability of your code, and especially the naming in your code, because we know that NP starts for naming problem, so NP hard means a problem is as hard as naming things, which is the hardest problem we know of. Naming is really hard. This is why sometimes, in my opinion, comments help. They also help to explain algorithms that might not be easily refactorizable but are needed in a given place. So I try not to comment my code because I always consider a code comment failure in naming things and refactoring things, but sometimes it doesn't make sense to spend like 3 weeks trying to refactor something just to get rid of a one-line comment. So how can you configure Rig? You can say that and those examples are from the Rig's defaults. You can say that data clamp is when there are at least 2 copies and there are like just 2 parameters are enough to consider something. Just 2 parameters repeated twice are considered a data clamp. But you can say, like, in my application, I'm perfectly fine if there are this happened twice. If it happens more than 5 times, then I'm worried that it's a data clamp. We have a long parameter list, which is we say that a method takes too many parameters if it takes more than 3 positional, and except for constructors, which we allow by default to take 5 parameters, because in practice constructors sometimes take 5 parameters, and constructors are hard to refactor when it comes to what they take, because there aren't that many more ways to get into an object than a constructor. So we give it a little bit of leeway, but of course you can override it. That's the point of this slide. We consider a class has too many instance variables if it has more than 4. This is something that might be controversial for you. It used to be 9, so we made the switch to 4 fairly recently, because we considered classes that have 9 instance variables a bit too large. But you can adjust it. And we say that a method has too many statements if it has more than 5 statements, which again is a little drastic. But we exclude constructors because, again, refactoring constructors for their length is usually problematic when it comes to the end result. And also those excludes, you can configure it either on a global way, but you can also say, like, I want to configure it on only for the given method in a given class. Like, I'm aware that this method might not be pure, but I'm OK with the way it looks like. I don't want Rick to make it smelly. All the way to saying that any method that matches the given regular expression is perfectly fine. For example, we have very many, I don't know, helper methods that start with something, and they are all considered by Rick utility functions because they're helper methods. So I will get back to this in a second. But you can configure it. You can provide a name of the method, a name of a class, a method on that class. You can say regular expression to either, and it will work. And of course, this problem happens. First, I can have too many methods in a class. Then I can have too many code in a method. Something's got to give people pick one. Making Rick happy, in general, is a painful process. But in the long term, it usually teaches many good things. The thing that I really like about Rick is you can configure it in a code command. So we can basically say, I know this is a utility function, and I want to specify this here, not in the global Rick config, because if this method is ever moved somewhere else, it will probably get moved along with the comment, rather than a global Rick config would have to be adjusted. If this method is ever renamed, this comment will work just fine, whereas a global config would have to have the method renamed as well. The nice thing about code comments is you can actually override any particular thing in them. So if you say that, in general, a duplicate method call happens whenever there is more than 1 call, but in this particular method, I'm OK with making 2 calls, but I want it to smell again when there are 3 calls, you can say it like this. Like, this has a duplicate method call. I'm OK with it as long as there are only 2 calls. If there's 3 calls, please mark it again as problematic. And finally, per directory configuration. This is a fairly recent introduction. We're in the process of moving from Ruby on Rails to software engineering. Basically, things like app helpers are a big pile of utility functions. So we can say, like, anything in the app helpers directory, I'm aware it will probably smell of utility function. Don't bother me with this. Caveat emptor, making Rick happy with my code taught me the most about OOP in the last year, but always be critical of such tools. I think I drove this point home with almost each and every example, but always be critical. It's not Robocop, which you agree on, and then Robocop is right or not. Always, once you agree on a given offense. In the Rick case, unfortunately, this is much more squishy matter where it goes into your brain and tries to tell you that maybe you didn't design it properly, and you basically defend yourself saying, yeah, I designed it properly, go away. And like 3 weeks later, you realize, oh, if I move this piece of code there, maybe it would be actually a better design. Finally, these are 2 slides from Piotr Solnica's talk, Clean Code Cowboy. Correctness verified by test comes before concerns about implementation details, and designing interfaces is more important than implementation details. So first and foremost, before you go into your code and try to, you have this huge legacy project with 5,000 lines, classes. After actually refactoring, there are still 5,000 lines. There are bigger concerns than actually whether this one utility function should be moved somewhere else. First, make sure that your interfaces are simple and work properly, and then care about implementation details. And in the meantime, actually test them. And don't get into this situation when, I want to see a hacker movie where the protagonist just stares in confusion at a stack trace for a few minutes, no typing, no chatter. Don't refactor your code so well that when you see it next week, you will have no clue how it works. Debugging is like being the detective in a crime movie where you're also a murderer. This is actually the most humbling experience where you find a bug because you refactor something so well that it no longer works, but in a very subtle way. So again, don't paint yourself in a corner, but by doing something that some tools from some shady people who go into meetups, basically that tool tells you what to do. So to wrap it up, please do try out Rig on your projects. We have fairly recently created a Code Climate plugin, and if you use Code Climate, you can actually configure your projects to make Code Climate actually run Rig on it by default. This is a big thing for us. And don't be overwhelmed by the potential smells. When you first run Rig on your code base, it might tell you oh my God, 7,000 smells. We, again, fairly recently implemented a Rig to-do command that does what Rubocop does also has this flag which basically says, give me a file that whitelists everything wrong with my project, and I will go one by one rather than, because we had many times people say, wow, Rig, wonderful project. I ran it on my code once, and I got so depressed I never run it again. Don't, please let us know what doesn't work. We learned about that thing half a year later. So we hope that this will be a big stepping stone into people playing with Rig, telling us what doesn't work, and please eventually have fun with refactoring and enlightened whitelisting, and please don't shy from enlightened whitelisting. If you think your piece of code is okay the way it is, it's probably okay the way it is. YAGNI is this acronym, you ain't gonna need it. Don't refactor code that is a one-off thing that you run just to, you will never run it again. If you have an import script that seems to be working and you will run it once, and then you will deal with all of the things that seems to be working actually meant, probably addressing this import script, refactoring this import script for a week, might not be the best use of your time. YAGNI, you ain't gonna need it. This is also why I actually put a lot of constants in my code without properly making them, constants, because in many cases they are only ever used once and in the given code base, and it makes the code clearer to reason about when you see some of them. In other places, actually refactoring is a problematic. And finally, the code is more what you call guidelines than actual rules. Again, to finally drive this home, these are guidelines. Do what you want with them. Thank you so much. I'm Piotr. You can see the slides there. I'm Chastel on the internet in general. And I gave this talk at RubyConf Portugal last year, and it was a wonderful conference. If you want to go to a conference that is wonderfully organized and in a very nice place, please write something on Twitter with the hashtag #MadeRubyConfPT16 happen. They are probably on the verge of making the call, so the more people help, the better. Thank you so much. If you have any questions, then I'll be happy to take them.
Just one comment. Probably after introducing code smells, it makes sense to recommend for Ruby developers to read the refactoring and clean code books.
Yes.
They're still about Java, but you still need to read them just to understand what code smells you can have, how you can fix them, and what is wrong with it.
Yeah, that's a very good comment. I think as a community, we somewhat got over the whole haha Java, haha verbosity, haha why do they do it, everything so boilerplate-ish, Baroque ways, and especially now that other languages say all of those things about Ruby, we now start to see that maybe some of the ideas that we now rediscover and the Java people discovered 20 years ago, maybe some of them are actually valuable, and it's a very good point to read books on Java. They usually use Java just on general object-oriented language that everyone knows. It might not be the best object-oriented language to show stuff on, but if you go past the boilerplate, then actually those books are really good. And also some of them have Ruby versions. So there's like refactoring Ruby that has this.
Another one, kind of a code smell, which actually indicates that interface or that architecture is tests. So when tests are hard to set up, it means that your interface sucks. If test is too big, it means you have too much functionality in your code and so on.
Yes, that's also a good point. If writing tests is hard, then it means maybe the code under test is not only hard to test, but actually hard to work with. Any more questions? Okay, thank you. Oh,
One more comment.
you need to do a lightning talk.
About the lightning talk, the fixed function which was counting bits by shifting, it was doing redundant checks. You can just shift and add to the count.
Right. That's a good point. There are like the whole. It might be the academic in me, but you know the whole problem of population count is so popular. A lot of problems boil down to it that it was really interestingly implemented in many different ways. So if you're into those kind of things, I kind of feel sorry for you, but there are a lot of materials to make you happy. So please also talk to me about this if you want to afterwards. Thank you so much.